So we have been talking about mixed numbers and improper fractions, and we learned that a mixed number is simply a number that has a whole number and a fraction with it. We said that an improper fraction is when the numerator, the number on the top, is larger than the denominator, the number on the bottom. So today what we're going to do is we are going to focus on how to add and subtract mixed numbers. So let's go ahead and look at our model back here. Here you can see we have one complete whole here, one complete whole here, and we have 1/4 of a whole here. So we're going to write it as 2 and 1/4. Down below here, you can see that we have one whole and a quarter, or 1/4. So we're going to write this as 1 and 1/4. What we're going to do here is add them together. You can probably see pretty easily by looking at the models here that if we add these two together, in all, we're going to end up with 1, 2, 3 wholes. And then if we combine our fourths, we're going to end up with how many fourths? 2/4. But interestingly enough, if I look at this and put both of these on here, you can also see that this is the same thing as a half. Or to split that whole up into two parts, we would have a half. So it would actually be 1, 2, 3, and a half. Now let's go ahead and do the math behind that and see how we come up with that. When you have mixed numbers, you're going to want to go ahead and stack them, just like when we learned how to add and subtract fractions. I told you to stack them on top of each other. So you're going to want to do the same thing here. So all we did was we took 2 and 1/4, which represents this model, 2 and 1/4, and we are adding it to this model, 1 and 1/4, right here. And now what we're going to do is we're going to start with the fractions. What did we say has to be true about fractions when you add them? They have to have the same denominator. So let's make sure that we do. Here we do have the same denominator. It's a 4. So we're going to go ahead and bring the denominator 4 down into our answer. Then we're going to simply add our numerators. We have 1 plus 1, which gives us 2. At this time, what we're going to do is then we're done with the fractions, so we're going to take a look at our whole numbers and we're going to add the whole numbers. 2 plus 1 is 3. Notice when you write a mixed number, you want the fraction line to be sort of in the middle of your whole number because you don't want to do something like this. See what I did there? It almost looks like 32/4 here. So you want to be very careful that you make it clear that you have a whole number, and then this is definitely a fraction. So we have 3 and 2/4. Now what we have to do is say to ourselves, am I able to simplify? Remember, all of your answers when you're dealing with fractions need to be simplified. So can we simplify 2/4? Sure. The common factor that we can divide this by would be 2. So we're dividing both 2 and the 4 by a common factor of 2. And that gives us, we're going to move our 3, our whole number, over here into our answer. That's not being divided by 2, so we leave that alone. We're just dividing the fraction here. 2/4 divided by 1 whole, which is 2 halves here, equals 1 half, which is what we figured out with our model. Let's try another one. All right, let's try. Let's do 4 and 2/3 plus 1 and 1/6. All right, that might be a problem that you might see. So let's go ahead and see what we would do. First of all, step 1 is to stack them. I'm going to leave this one alone. I'm just going to bring this number down here. Right away, I can see here that I have different denominators, so we have to make them like in order to be able to do anything with them. So I'm going to make equivalent amounts. So I'm going to go ahead and set myself up to make equivalent amounts. Remember, when you're doing this, please make sure that you remember to bring your whole number over into your workspace. I've seen so many people focus so much on making equivalent fractions that they do all the work and they add or subtract the fraction, but then they forget about the whole number. So if you keep them together as a unit, it's going to be helpful for you. So bring your 4 over, bring your 1 over from your whole numbers. Now let's focus on our fraction. We can't do anything with them right now because they are not like. They are unlike fractions. They have different denominators. So what multiple do they share? What multiple does the 3 and the 6 both share that's common to both of them? Well, you can use a lot of different things. You could use 36, you could use 12, you could use 18, you could use 24. The list goes on and on and on and on and on. I'm going to use 6. 6 pops out to me because I know that 6 is a multiple of 3. How do I know that? Because I can use 3 times something to get 6. How do I know 6 is a multiple of 6? Because I can use 6 times something to get 6. Okay, so I'm going to use the common denominator here of 6. Now I have to figure out what my missing numerator is going to be. How many times does 3 go into 6? Twice. In other words, 3 times what equals 6? 3 times 2 equals 6. Whatever I do to the denominator, I have to do the same thing to the numerators, which means I'm multiplying the 2 in my numerator times 2, which gives me 4. Down below, you can see here that I'm using the exact same amount. So all I'm going to do is just transfer the 1 over. Okay, now I have a like denominator. So I'm going to bring that down into my answer because when you add and subtract, you keep the same denominator. And I'm just going to add my numerators. 4 plus 1 equals 5. 4 plus 1 as a whole number here equals 5. I ask myself, can I simplify that fraction? The answer is no, it's already simplified enough. The only common factor that they both share would be 1. So 5 and 5/6 is going to be your answer. All right, let's do one more. I would encourage you to get out a piece of paper and try this. If you haven't been doing this with me at all, go ahead and get out a sheet of paper and see if you can do this. These kinds of problems are going to be found on page 679 of your book. And so I would encourage you to practice some. You will have some assignments where you're going to have to practice some of these at home, but you can practice the ones in your book here. All right, I'm going to practice number 4 on page 679. It says 5 and 1/12 plus 6 and 1/4. Okay, go ahead and do that problem. See if you can get the answer, and then I'm going to do the problem as well and see if you get the same answer. All right, so I noticed right away that I have different denominators, which means I'm going to have to make equivalent amounts. I'm going to use 12 as my denominator. So far in the examples that I've shown you, one of the denominators in the original part of the problem has happened to be one of the denominators that I can use over here as a common denominator. It won't always be that way, and that's okay. So I don't want you to think that just because I've always been able to use one that's in the original denominator problem, that it's always going to be that way. It's not. It just so happens to be the way it is right now. In this case, 12 will work. 12 was right here, so I'm not changing anything here. I'm leaving that amount the same. Over here, how many times does 4 go into 12? Well, it goes in 3 times, so that's what I'm multiplying my 3 or my 1 by to get me 3. Then I'm going to add my numerators to get 4. I'm using the same denominator that's there, and I'm adding up the whole numbers. 5 plus 6 is 11. Can I simplify that? Yes, I can. I can simplify 4/12. Could you think of something that I can simplify that by? Okay, some of you might say, yeah, I can see right away you can simplify it by 2. Okay, when you do that, you would get 2/6. Then you would say to yourself, can I simplify that again? And you can. You can also simplify that again by 2. I also can see right off the bat that I can simplify it by 4. So here's my whole number I'm bringing over. 4 divided by 4 is 1. 12 divided by 4 is 3. So my answer would be 11 and 1/3. Hopefully that is helpful to you. All right, let's shift gears here a little bit and do some subtraction. The same thing that you do in addition, you're doing in subtraction, except you're subtracting. So you don't have to learn a whole new style for that, which is kind of nice. Let's go ahead and do some of these. Okay, let's go ahead and do 6 3/4 minus 2 and let's say 1/3. Okay, when I subtract, I do the exact same thing. I have to see whether or not I have common denominators. In this case, I don't. I have a 4 and a 3, so I'm going to have to find something that's common to both of them. That means I'm making equivalent amounts, so I'm going to pull over my whole number right away so I don't forget to do that. And the common denominator that I can see that I'm going to use here, I'm going to choose 12. Again, you could use other options, but I'm choosing 12. How did I get that? Well, remember, when we do our popcorn method, we're listing all the multiples of 4 and all the multiples of 3. The first multiple of 4 is 1 times 4. The first multiple of 3 is 1 times 3. I would keep going back and forth until I found a common answer or a common multiple, and 12 is the first one that I'm going to come to. It's not the only one I could use, but I'm just choosing to use that one. If you ever get stuck with this and you're not sure, you can always multiply the two denominators together. That will also work. Okay, so 4 goes into 12 3 times. So I'm multiplying my numerator times 3 to give me 9. Down here, 3 goes into 12 4 times. I'm multiplying my numerator times 4 to give me 4. My sign tells me to subtract. So I'm going to say numerator minus numerator, which is 5. I'm using the same denominator that I have been given. Now I'm going to look at my mixed number, my whole number, and focus on just that. 6 minus 2 is 4. I would ask myself the same question. Can I simplify 5/12? In this case, I can't. The only common factor that 5 and 12 share is 1, so it's already simplified. So that is my answer. That is what you do when you are adding and subtracting mixed numbers. Now we're going to take it one step further. What do I do when I have something like this? I have 3 2/3 plus 1 and let's say 4/5. I can see that I am adding, so I'm going to look at my denominators. They are different, so I need to make them like. A common denominator here would be 15. How many times does 3 go into 15? 5 times. So 5 times 2 is 10. How many times does 5 go into 15? 3 times. 4 times 3 is 12. I have common denominators now, so I can go ahead and pull that denominator down into my final answer. Give me 15 here. And now just add my numerators. 10 plus 12 is 22. And then I can say with my whole number, 3 plus 1 is 4. That looks a little crazy, doesn't it? 4 and 22/15. Well, what do you notice about 22/15? Well, that is improper. Part of when you're simplifying your final answer, you have to look at this kind of thing because we can't leave this like this. We need to do something with this. We learned before how to change an improper fraction into something that's acceptable. All improper fractions will always be acceptable in one of two ways. When you change an improper fraction, when you divide the numerator by the denominator, you're going to end up with a mixed number or a whole number because it can come out evenly. For instance, if I have an improper fraction of 20/50ths, that means 20/5ths. That means I have little fifth pieces and I have 20 of them. How many wholes is that going to give me? Well, 20 divided by 5 equals 4. So in this case, I'm just going to end up with a whole number. It's not going to be a mixed number because there aren't going to be any leftovers. But if I have, let's say I have 21/5ths and I take 21 and divide it by 5, do the math on that. Here I'm going to end up with one extra piece. So I would have 4 wholes and 1/5. So hopefully that makes sense to you. That's just a quick review of improper fractions. But let's go back over here to our problem that we're dealing with. We ended up with 4 and 22/15. That means that our whole is divided up into 15ths. And I have 22 of them. Well, because I can see that I have a greater numerator than denominator, that tells me that I have at least one whole set here. So 22 divided by 15, 15 goes into 22 once. 1 times 15 is 15. When I subtract this, I get 7 7/15ths. So I have 1 and 7/15ths. Okay, well, what does this represent? It represents just the 22/15ths. So I can put 1 and 7/15ths in place of the 22/15ths. They are equivalent amounts. If I had pizza and I cut the pizza into 15ths, I would have one whole pizza cut into 15 slices, and they would all be there. And then I would have 7/15ths of the next pizza. Another way of saying that is, well, how many slices of 15s do you have? Well, I have 22 of them, 22/15ths. So these two amounts are equivalent right here. So what I'm going to do is I'm going to call it 1 and 7/15ths. I'm calling 22/15ths 1 and 7/15ths. And I still have to combine my original adding of my whole number here to when I got a 4. So I have to combine these two amounts. Well, 4 pizzas plus 1 and 7/15ths pizza is going to give me 5 and 7/15ths. I add my whole numbers, 4 plus 1 to give me 5, and I bring along the 7/15ths. So my final answer, I'm running out of room here, my final answer would be 5 and 7/15ths. I still need to ask myself, can I simplify this part of the fraction? I can't. It's simplified already. So that would be my final answer, 5 and 7/15ths. I hope that makes sense to you.